Okay, let's look at finding slope and rate of change, the guided notes section. So some of this is a little redundant, but we'll go through it nevertheless. And you'll definitely get to check your checkpoints or do your checkpoints as well. So the first part is just finding slope of the line. So like I was saying in the other video, this is the formula we use, right? So basically when you label them like this, the ratio of the rise is your change in y, so that's your y2 minus y1. And think about it, whenever you want to find the change in something or the difference in something, you subtract. If you want to figure out your change in your height from 1 year to another, you would subtract, okay? And then this would be your run, which is your change in x. So again, this is your rise. This is how you find your run. So we can write it here, rise and run. Change in y, change in x. But like I was saying to you yesterday in the meet, this is kind of misleading because your rise might be negative, which means you're falling. So it could be a fall and a run. So I'll even put rise slash fall over run. So I'll give you an example of that here. So this is, first of all, is this a positive or a negative slope? Yeah, puff, puff, positive. And it rises. To find the y, rise, you do y2 minus y1. To find the run, you're going to do x2 minus x1, and that'll give you your run. Similarly, if I made another graph here, this x, this y, and I'll go here and here, okay? This is what I was talking about. So again, your rise over run, really this is going to be a fall, and then a run like this. So like Slope Dude mentioned, you're always measuring or calculating your line from east to west, so left to right, and this would be from left to right. This is a down and to the right, so it's a negative fall and then a positive run, if that makes any sense. And it will, the more you practice with it. So on the next page here, we're going to find the slope of the line shown. Okay, so here goes. So let's do it both ways. So I'm going to take a moment to do it the formula method, and then I'm going to go back and just show it to you on the line, because both are acceptable ways to do that. So if you look here, let's do the formula method for this. So for part A, I'm going to write it here. I'm going to write, so it's 2 points, -1, 2, 3, 5. Okay. So when you label this, you're going to label this x1, y1, x2, y2. So when you fill out your y's, you're doing the 5, the second y, minus 2, and the other one's going to be 3 minus -1, okay? And when you substitute and simplify that, you're left with 5 minus 2 is 3, and this is going to be plus positive 4, so it's 3/4. So you would say the line rises from left to right, and the slope is positive. Okay, so if we kind of look at that in our example here, you could have, if you're given a graph, there's really no need to do that whole formula. So let me just show it to you here. Okay, so I could just find that if I'm given the graph, I'm just going to do rise over run. So you always kind of have to pay attention to the axes. So these are up and down. This is units of 1. This is units of 1. So you're literally just counting the boxes. So here's our change in x, which was the 5 minus the 2. 5 minus the 2, which was 3 units, right? And then our run, do it in red, was this way. A change in y, which was 3 minus -1. which gave us 4 units. So 1, 2, 3 rise, 1, 2, 3, 4 run, just like we were doing in the meet yesterday, kind of rising and running. So it looks like that. All right, let's do the next one here. I'm going to try to, this time I'll put the coordinates kind of left and right of each other, not horizontally. So here for B, coordinates we're looking at are 1, 4, and 3, -2. Okay, label my stuff, x1, y1. I'm sorry, it's going to go up here. X2, y2. Now I'm just going to subtract my y, so it's going to be -2 minus 4. Again, those arrows really do help me, so I always go like that. And then I'll do it in a different color here. My x's are going to be b. So now I'll do x2, which is 3, minus 1. And of course, that's pretty easy to simplify. That's going to be -6 over 2. And then -6 over 2 simplifies to just, oops, sorry, I had space for it down there. Sorry, I should have put it over here. Let's go with it, -3. So that's your slope. So in this case, the rise, it's more, the line falls, if you will, from left to right. So it's going in this direction. It's falling from left to right, and the slope is negative. Okay, so in this part of the video, or the Ed puzzle, I want you to try the checkpoints at the bottom. And if you could enter your answer to question 1, if you could enter your answer to question 2. All right, if you did that right, hopefully you got these numbers. So hopefully number 1, you got 2. So again, it's 1. The arrows always help me like this. My y's, 1 minus -1. My x's would be -2 minus -3. 2 over 1, which is 2. The second one, I'll label it up for you. Sometimes when I label it, I just go like this. Like I follow the formula. Y2, Y1, X2, YX1. So -2 minus 3, -5, and 5 minus -6 is 11. So -5 11s for that one. Okay, let's look at these examples. Example 2, finding the slope of a line. Okay, so things are going to be a little different here. So you can already tell, or maybe you can't because it's so hard to kind of see. So we already know from Slope Dude for these 2 examples what kind of slope we're going to get. Well, let's just prove it with the formula, because sometimes you'll literally just get this, and you'll be like, all right, find the slope. And it's one of these will have a 0, either the numerator or the denominator. And then you have to remember, if the 0 is in the top, is that a slope of 0, or is that a slope of undefined? Same thing if the slope's at the bottom or denominator, is that a slope of 0 or a slope of undefined? So, well, kind of, all right, I won't give it too much away. So let's do A and B, just kind of, I'm going to go a little quick here, just the way we did on the other page. So this is A, 2, 5, -4, 5. So we're going to do x1, y1, x2, y2. Subtract my y is going to be 5 minus 5. Subtract my x's is going to be -4 minus 2. So then when I simplify, I'm left with 0 over 2. So would you look at that? Interesting things to notice, okay? So things I noticed, the 0's at the top. The y coordinates are the same. So that makes sense. There's no change in your up and down. 5 minus 5 is just 0, okay? So if you ever notice that the y's are the same coordinate, spoiler alert, the slope is 0. So, and I think I mentioned this in the previous video, I'm going to write here m equals 0. The slope here is 0, okay? So what I want you to remember, if the 0 is at the top, you're always going to have a slope of 0. And that makes perfect sense, because if I did anything in my calculator, 0 divided by 36, 0 divided by anything is 0. Okay? So now let's see what happens when I do an example B. I bet you can predict the sequence here, but I'm going to do it anyway. So 4, -2, 4, 3, x1, y1, x2, y2. Do my subtraction, 3 minus -2. Uh-oh, my x's are the same. Oh my goodness, 4 minus 4. So my x's are the same, so now my change left and right. Look at my, does it really change left and right? All the way down, am I really changing from left to right? No, I'm not. So your change from left to right is just going to be 0 at the bottom. Sorry, just make sure you know that with the denominator. But my y change from up to down is 3 minus, it's positive 5. Okay? So with this is if we had slope dude here doing his thing, and he hits this part of his thing, then we're going to swear and curse. We're going to say undefined. Okay? So that is undefined. The line has, when you simplify this all the way, the slope is undefined. So I found this image, I think it was last year, and I had to share it with you because this will help you remember. Again, 0 is at the bottom, undefined. 0 is at the top, it's a slope of 0. And of course, if you didn't know, you can't really divide by 0. Sorry, it's not the image I want to show you, but if I did like 65 divided by 0, it says error. It will always give you an error. It's undefined. But the image that I wanted to share with you here is this. So this is how I've always, once I found this, it was like almost foolproof. So if you think of the word no, it's no with the 0 at the bottom, that's undefined. No, that's not acceptable. No, that's undefined. But then if you did okay like this, 0 at the top is okay, and you call that a slope of 0. Found that image last year, somehow those images, and I was like, whew, that's a good way to look at it. So again, no, undefined, 0 at the bottom, 0 at the top, that's a slope of 0. All right, so got some more checkpoints here for you to do. Checkpoints 3 and 4, find the slope. I'll tell you one of them will be 0, one will be undefined. In this part of the video, if you could enter your answer for number 3, if you could enter your answer for number 4. Hopefully you got them right. Did you get for number 3 undefined with the slope with the 0 at the bottom, and number 4 slope with the 0 at the top? So pause the video and take a look if you don't understand this. Okay, and then the last part of the section here, which we're not going to go into too much, but I figured I'll just go through it quickly. It's not always about like the numbers. Sometimes rate of change has to do with real world examples. So it says gas prices. The table shows the cost of gallons of gas for numbers of days. Find the rate of change. Like I told you in the previous video, that means the slope with respect to time. Okay, so if you think about it, these are your x values. It's your independent variable, and this is your y values. It's your dependent. The price depends on how many days have gone by. So if you want to find rate of change, you're really just finding the slope, so the change in cost and the change in time. So it looks like it's choosing this day, day 3. And maybe I'll choose, it really would work if I choose day 1 or day 5, it doesn't matter. I'll choose day 5 just to be a little different, okay? So if I write these as coordinates, right, my x is 3, and then my price of gas is 209, and this would be x of 5 and price of gas of 219. So now I just do my slope formula, which is my rate of change formula, and I'm going to do 209 minus, what? Yeah, wait, I should have chose that. That's what it wanted me to do. But I'm not going to go backwards now because this is my x1, y1, x2, y2. So really the way I should write this according to my formula is 219 minus 209. So it happens when you try to be different. And then 5 minus 3 will give me the same answer. It won't matter. When I simplify this, I'm left with 2 over 10 cents, right? 0.10. So what's half of 10 cents? 5 cents. So the rate of change is 5 cents per day. All right, so this question is the last checkpoint you'll be doing today, number 5. The table shows the temperature over time. Find the rate of change of degrees with respect to time, okay? So let me just make sure I set you up on this before you enter your question here. This one's set up a little different. So the dependent is really over here. These are your y's. The temperature depends on the hour, okay? So for example, I don't know, you can really choose anything you want, but say you were choosing these right here, you would write this coordinate as 243. It's a little backwards for that. So good luck. If you could enter your answer for number 5 now. All right, if you did it right, hopefully you got 2.5. Here are my choices, or here's what I chose to do. So hopefully I did this right. So yeah, again, it's a little awkward the way to write this. So this is really 653 and 243 that I chose. And again, you could choose any two coordinates on this table. As long as it's linear, constant rate of change, it's going to work. So I did 53 minus 43, and I got 10. 6 minus 2 is 4. You can reduce that to 2.5. So if you entered anything like 2.5, you are correct. So now you're going to get a chance to try some classwork, and good luck with